sketch the graph of y is equal to the square root of x minus 3. Now, the way I'm going to do this is I'm going to compare this to the base function, y is equal to the square root of x, and then transform the base function into our new function. And so the general form for transformations is like this, where a is in the front, that's our vertical stretch, b is our horizontal stretch, h is our horizontal shift, and k is our vertical shift. And you can see we only have an h value here, x minus 3. And actually our h value is actually positive 3 because it's minus the h value. And so, in other words, h is equal to 3. And remember, it's the horizontal shift. And so it's positive, so it's 3 units in the positive x direction to the right. And so that's the only thing. So if we take points on the original y equals square root of x, and we transform them to our new function, all we have to do is add 3 to the x coordinates. So here are just some generic points on the original function. I chose x values that are all perfect squared because the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. Again, all I did was add 3 to the x coordinate. I'm going to get these 4 coordinates, which are on our new graph. And if you plot them, it'll look something like this. Again, you can see normal square root function starts about here, goes off, and you can see all of them have been moved 3 units to the right. Now, as for the domain and range, again, the part underneath the square root must be positive, like any square root. And so it has to be, or not say positive, greater than or equal to 0. It can also be 0. And so x has to be greater than or equal to 3. And so we write this as close bracket 3 all the way to infinity. You notice we can go from 3 all the way to infinity for our x values. For our y values, again, it goes from 0 all the way to positive infinity. And so we write it as 0 to infinity. We can also take a look at a graph of this. I have the generic function, 4 points that were on the generic function. Then I have our transformed function and 4 points on the transformed function. You can see the orange, that's the generic function. You can see how it's the square root of x. And you can see how all the points on this function have just been moved 3 units to the right.